Hey guys, welcome back. Well, I'm going to show you this thing we just got done building that doesn't work. But, oh well. So we bought this up here. This is like an air misting kit. So I've kind of modified it to make it work, but essentially this line just goes into oil, which you can see here. I got a thing with oil in it. That's the spindle oil that finally came in. And then for the air, I had to go buy a bunch of fittings, and we hooked up an electric solenoid so that I could turn this on and off. And then that just goes to a hose that runs outside and plugs into the air system. So far pretty simple. Now here's the hose that comes out of that. You can see, maybe you can see that, but anyway, this hose, normally this would just spray on whatever you're machining. So what we did was we hooked this piece of hose and another piece of hose, and this comes out right there. Easy enough, plug it into the mill. So far so good. And that would be good, but we have a problem. This actually works until you plug it in. As soon as you plug it in, it don't work anymore. So I'll see if I can show you. Alright, you see that hose? So right now, I'm going to put this just kind of pointing up here, and watch what happens. There it goes. So it works. If you noticed, you'll have seen that it pulled oil up through this hose, and then a few seconds later, we had an oil mist coming out. But there's a problem. The problem is when we actually hook this up, it doesn't work anymore. So we're going to connect that hose up to the spindle, and we're going to do the same thing. And watch what happens. Watch the bottle. It blows bubbles in the bottle. So, let me tell you what's happening. So essentially this venturi is pressurizing due to the hose, and it's causing it to backfeed and basically do the opposite. Instead of creating a vacuum, it creates a pressure. So then instead of pulling oil out of the reservoir, it just blows air bubbles into the reservoir. So, yeah, unfortunately, I actually did think of that, and I was like, I wonder if that'll happen, but I kind of didn't think it would. I thought we'd be okay. And we weren't. So I've tried messing with it, different pressures, different valve settings. The good news is we have got a bunch of oil in the spindle, but just from having air in it, or anyway, irregardless, this ain't working with that setup. So might seem like all is lost, but check this out. Here's the backup plan. This is called a lubricator. It's actually designed, you hook it to your air tools, or well, you hook it to your air compressor, and it you put oil down in here, and while it's supplying compressed air to all your air tools, it adds a little bit of oil in the line. And we ordered this at the same time that we ordered the misting thing. I actually didn't know about these. Well, I didn't think about it, let me say that. So we bought this too, just in case the mister didn't work out. We'd have a backup plan, which I don't know if this will work, but at least this is designed to work with air pressure like this. You know, it's designed to supply pressurized air and have oil in it, but I don't know how much oil. But it is adjustable. This wasn't clear so much when I bought it, but on the top here, you can see there's some numbers, and you turn this little plastic thing, it's kind of chintzy, but and it's got a little baby reservoir. This thing holds 0.8 fluid ounces is what it says. So not much, but let's see if it actually works. This is going to be our second option. So at this point, I got to take apart the system I just got done building, which is awesome. And then I'm going to see if I got enough fittings to actually rig this up and try it out. And we'll go from there. Alright, good news. This thing's looking promising. So check this out. It actually drips oil. Drop right there. Here comes another one. Drip. And that part's adjustable. So I got it slowed down some right now to go slower. So that's working. Check this out. So I'm going to take this rag. Watch what happens. As you can see, getting a little bit of oil coming out. So, awesome. That was simpler than the other setup, and that works, and it's adjustable. Now we just got to get the right. I don't think I actually have the right fittings. Maybe I do. We gotta plumb this and get it to here. And then we gotta figure out how to mount this to where we can actually service it. So this is just dangling right here. But okay, that's good news. This is gonna be easier. Alright, well, unfortunately we don't actually have the right fittings right now. So this is quarter MPT, and we need to go, actually we just need a quarter MPT to quarter nipple. Actually, maybe I do have that. No, I don't. I think this is 1/8. Yeah, so this has a quarter nipple, but it's 1/8 NPT. Yeah, that won't work. You know, I might could figure this out. Maybe hook a fitting into a fitting or something. Let's see. This, I might could rig that. Yeah, I could probably do 3 different pieces. This piece to this piece, and then this into that. I could rig it up. Maybe we'll do that. Alright, so can't say I'm proud of it, but we did a fitting into a fitting into a fitting to a piece of hose, and that gets us to here. Alright, so we just cranked up the volume. As we can see, it's dumping a ton of oil now. Look at this. Alright, so that's way too much. I'll back this off. That's probably still too much. Alright, that works, but it's slow. I'm not quite sure how we're going to do this, because we intended for this to be something that we only use a few seconds, whereas this is kind of more continuous use, just let it spray all the time, which would admittedly go through a lot of air if we actually did that. Also, that drop is holding on forever. But this is working. Getting a slow miss. Yeah, I think that's a little too slow. No, that's probably too fast. But, let's try it anyway. Yeah, so it looks like whenever it drips, it just blasts out a drop of oil. It's not really a good mister. I bet you higher air pressure and less oil would work better. Alright, so I didn't really video that. I turned the pressure up and this whole hose just started flying around. But yes, more air pressure, it does mist better. So at this point, I think we're going to hook it up to the spindle and actually turn it on and see what it looks like from there. So there's like a whole fog of this stuff coming out. Through here, through the bottom. Alright guys. So we ran the oil system and kind of made sure all the bearings got a nice initial oiling. And we just turned it on. So we got our spindle at a 2600 override. And it's only been running for like 20 seconds maybe. Still pretty quiet right now. Maybe quieter than before, I'm not sure. But we're going to let it run and see what happens. So right now, 90 degrees. We'll see what happens. Also, we're at 2.9 amps at 2600. Alright guys, we started off at 90. It's been about 2 minutes. 90.5. LOL. Yeah, I kind of wish I'd done that 2-minute test on the old one. But we'll see after 5 or 10 minutes. Normally it would be up at 150 is where it would end up. After, say, I don't know, 10 minutes. We'll let it run 10 minutes. We'll see where we end up. Alright, it's been 6 minutes. We're at Okay. I wonder if that's right. Huh. Well, put that in your pipe and smoke it. It's been running 6 minutes and it actually went down from the last reading. Huh. Well, I'll be curious to see what it does at higher RPMs, but like I said, it used to get up to 150 at 2500. We're going to let it run. It's only been on 6 minutes, but I would say that's promising. Let's see what it looks like here. 90.3. 90.3. Huh. I mean, it doesn't feel warm, so... Huh. Well, I don't want to jump the gun, but this is looking like a huge success so far. At this point, we should have just crossed the 7-minute mark, which we did. I guess we're going to end up waiting probably 20 minutes just to see. I really want to speed it up, but maybe we'll go to the 10-minute mark. I know at the 10-minute mark, this sucker would have been at probably 130 by then. So we're going to let it run for, say, 10 minutes, and we're going to speed it up, see what happens. Alright, guys. So we set up our oil system. We've had the spindle running for exactly 10 minutes now. We started out at 90.0 degrees. Let's see what we're up to. 90.3. Okay, so it basically hasn't changed in 10 minutes. Well, we're about to go up. Let's see what happens now. Alright, so we just went up to 4,000 RPMs. There's our speed override with 4,000. Sounds okay. Let's see what our amps are up to. Yeah, the amps jumped up. We're at 4.1 amps, 4.2. We're going to monitor this one a little closer. Because what we saw before, temperatures would really take off at higher RPMs. So we just crossed the, now we haven't even run a minute yet. Let's just see. Not yet. But we're going to watch it. Alright, we've been about 2.5 minutes. We also did another oil. We plugged it in for like 4 seconds just to get a little extra oil. Let's see where we're at. It's been about 2 minutes or so at 4,000. 90.6. We haven't even went up 1 degree. This machine's been running for, I think, about 13 minutes at this point. Yeah, 13 minutes. And it hasn't even went up a degree yet. This is looking promising. Oh yeah, I will mention there's one unknown right now. So I don't know if I have the preload tight enough on the spindle. I kind of guessed at it. So when we start cutting, if we find out that it's chattering and we don't have enough preload, we'll have to tighten it. And that could cause the temperatures to go up. So even if this does look like a victory, we really won't know until we start machining. If it's cutting good and it's staying cool, then it's a total victory. But so far, very promising. Alright, this is 10 minutes at 2,600 and then 5 minutes at 4,000. Ooh, 94. It actually did go up. Check it again. Yeah, 94. Alright, so we're finally getting a little temperature. 4 degrees. Let's see if we can feel anything. Not a little, not much. Yeah, just a touch warmer. Just that upper one here. This is roughly where the other bearing's at. Roughly 93. Okay. Looking good. So last time we did 4,000, we shot up to 170. I think, or 160. It did that in like 30 seconds or something. So looking good. Alright, so we got 10 minutes to 26, 10 minutes to 4,000. We're at 4.1 amps, so check that. Let's see what we're up to. 95. We'll check this one. 95. So at 5 degrees over ambient at 4,000 RPM. We've had the spindle on for 20 minutes. Time to go up. I'll be honest, I really just want to go straight to 6. But we're going to run it at 5. Let it run here for a little bit before we go up. Sounds good. I can hear the rattle, a little bit of the case noise from the bearing. Not much, but a little. Fairly smooth. I know this is vibrating some. I need to get that, what's funny is this is actually pretty smooth. This isn't, because this thing's out of balance. And you gotta actually get around to making that part. But let's see if we get these bearings fixed first. Also at 5,000, we're pulling 4.6 amps. Alright, so we got 10 minutes at 2,600, 10 minutes at 4,000, and we're at 4 minutes at 5,000. Let's see where we're at. 99. Here. 98, almost 99. And then up here, this is where the bearings to support the pulley are. 132. It's a little bit hotter up here. Up here we got two bearings that have grease. They're ball bearings, not roller bearings, I believe. And they have grease on them. So it looks like these bearings are actually heating up more than the tapered roller bearings in oil. That's interesting. The heat from up here may just be kind of coming down, heating everything up. It may not actually be the bearings. So if that's true, we'd expect this one to be colder. I think they were the same, right? 100.4, about 100. So they're about the same. But anyway, yeah, we just crossed 100, so I believe this down here is going to show about 90. Yep, 89.9, so about 90. Back here, same. So we're 10 degrees above ambient. We've been running for, at this point, 25 minutes on the video, and we're up 10 degrees at 5,000 now. Alright, so we're at 6,000 on the spindle, which is 12,000 at the motor. We're pulling 5.7 amps on the VFD. Alright guys, the spindle's been on for half an hour. We started off at 2,600, we went to 4,000, 5,000, and then the last 10 minutes at 6,000, I think. Oh, that might be 40 minutes. Anyway, she's been running for a while. Yeah, probably 40 minutes. So let's see where we're at. 108. Check this bearing. 110. Let's check these greased ball bearings up here at the top. These are hotter. 137. Okay, yeah, 139, 140. These bearings up here are running in grease. Those are kind of hot. But these oil lube bearings, these are working nicely. And we got our air blast setup going. I'm going to show you that real quick. Just real quick. Yeah, it's hard to show the air blast, but it works. It puts a little fine mist of oil out in the air, which I'm sure is great to breathe, but hey, the bearings seem to love it. Alright, that's going to conclude our bearing breakdown / test. And that is a humongous success. So watch this. This thing's been running for probably 40 minutes. I can put my hand on it. It's not even that hot. So, yay! Success. Now, admittedly, this thing's just zip tied on there right now. Because, as you saw, we zip tied that other setup and we plumbed it all together and we kind of halfway did it. We didn't even wire it up, actually. And the reason was, I had a feeling, I was like, well, if it doesn't work, you know, then it would be for nothing. So, that's why we did this zip tie and just throw it together. But the second setup did work. I'm very happy about that, because when the first setup didn't work, I was like, man, we got this backup system. That's why we bought it, just in case. And luckily it paid off. And this is actually simpler. This, you know. So, yeah, pretty awesome. What we don't know is if the bearing is, if this is tight enough. I mean, I can't feel anything. I don't feel any, you know, looseness. Not really. Man, that spins so freely now. Man, that's awesome. But yeah, we don't feel any looseness. Hopefully it's okay, but it is late. I gotta go to work in the morning, so we're gonna have to knock off. But I think our plan will be the next day, tomorrow. I don't know if I can upload this video tonight because I'm sleepy. But anyway, tomorrow we're gonna do some test cuts. Here's our material. And you can actually see this thing's coated in oil from all the oil we've been spraying. But anyway, yeah, we're gonna do some test cuts next time, see how it does. And plus, we'll finally get to try out our 6,000 RPMs, which we have not done. This last cut we see, that was at 4,500 RPMs. We haven't went higher. So, we'll get to try that. And, I can't tell you, I'm not going to tell you what it is yet, but you see this guy, This is a 5/8 2-flute indexable end mill from AccuSize or something like that. I got a new one, and it's bigger, and we're going to try that one out too after we get done with this. And I got another one ordered that we're going to try as well, but it's not here yet. So y'all stick around. We're going to have some testing coming up, and the if everything goes to plan, we're going to have some cool videos coming up in the future. All right, y'all, take it easy.